I am on page 8 in section 8.2. The example at the top says the drug Lipitor is meant to reduce total cholesterol and LDL cholesterol in clinical trials. 19 out of 863 patients taking 10 milligrams of Lipitor daily complained of flu-like symptoms. Suppose that it is known that 1.9% of patients taking competing drugs complain of flu-like symptoms. Is there evidence to conclude that more than 1.9% of Lipitor users experience flu-like symptoms as side effects at the alpha equals 0.01 level of significance? So first of all, we realize that there is a total number that we have for our sample, and that would be our N value. And also I'd reread the problem again. It's always good to read these problems twice at least before jumping into them. So this is 863 is our N. X is the number of people that have these flu-like symptoms, which is 19. Then I ask you guys usually in class, what is the parameter that we're talking about? Is it proportions? Is it mean? Is it standard deviation? And the key that gives this away is that it's a percent that we're talking about. So it says more than 1.9%. And since we're talking about a percentage there, that's the same thing as a proportion, just written as a percent, not a decimal. And so coming up with our null and our alternative hypotheses, I'm going to go ahead and put P's down for both of those for proportions. Our null always gets an equal, and I'm going to go ahead and write that 1.9% as a decimal, so 0.019. For all our alternative hypothesis, it does say more than, so greater than 0.019. And so we have N and we have X in our P naught value. On our calculator is 0.019. And the first thing that we should have done was actually verify that this test could be done. It's on the filled-in notes that are posted. Those are those 3 things that you would have to check. And you leave that up to you guys to check on your own. When you guys have this, we are going to go to one prop Z test and enter all those in. Select greater than for your alternative. It will give you the wrong answer if you have the wrong symbol selected for your alternative. Select calculate and enter, and you should get a p-value. And the p-value that I got, and again, p-values are probabilities, we're in around 4 decimal places, is going to be 0.2582. And this is greater than alpha. And alpha for us this time was equal to 0.01. And since this is greater than 0.01, we can conclude that we do not reject H naught. So we need to write our conclusion. So this is going to start off with there is. And it's not sufficient evidence again, you could say insufficient instead of not sufficient evidence at the alpha equals 0.01 level of significance to conclude and when you guys are stating what you conclude, it's usually written up here, and so you can kind of just steal it. So it says to conclude that more than 1.9 of Lipitor users experience flu-like symptoms. So I'm going to go ahead and write that in down here, but it's usually written pretty clearly in the word problem. So to conclude that more than 1.9% of Lipitor users experience flu-like symptoms. And again, what you are concluding right in here what we concluded should match with what you're talking about in your alternative hypothesis. The second problem says in 2000, 58% of females aged 15 years of age and older lived alone, according to the U.S. Census Bureau. A sociologist tests whether this percentage is different today by conducting a random sample of 500 females aged 15 years of age or older and finds that 285 of them are living alone. Is there sufficient evidence at the alpha equals 0.1 level of significance to conclude that the proportion has changed since 2000? Assumed test criteria has been met. So again, I noticed that we have a sample size, and our sample size is of 500 females. And we're asking about the fact if they live alone. And we have down 285 of them are living alone. I noticed when reading this word different, and different means not equal to. We saw that back before in the earlier section. And so not equal to, and then I'm going to ask you guys, what's the parameter that we're using? Is it proportions? Is it means? Is it standard deviation? Is it variance? And again, I want you guys to realize there is a percent in there, and that's kind of one of those things that allows us to kind of think it's a proportion. So we're going to say H naught and H1. I'm going to put P's down for both of these, and equal sign for my null. I'm going to say equals 0.58. And H1, since it does say different today, I'm going to say not equals to 0.58. So my P naught value is equal to 0.58. And again, using one prob Z test, putting all those values in, making sure that you have not equals to selected. Go to calculate, select enter, and you should get a p-value. P-value that I got was rather large. It was 0.6505. And this is definitely greater than alpha. And alpha this time was 0.1. And this means we do not reject our null. So do not reject H naught. Okay, so now we need to write our conclusion. So there is not. And the little trick here is that it does say, if you do this the way that I'm doing it, it does say not here. So cheap and easy way of doing this is just rewriting the word not up there in my conclusion. So there is not sufficient evidence at the alpha equals 0.1 level of significance to conclude that and we're talking about the proportion of females living alone has changed or is different than the 2010 level of 58%.